Oh, we have to use the applet, it looks like. Okay, I'm going to open it.
Yep.
What happened to hello?
Can you take a break? Go do the chicken squid. And the problem is going so well, and it's only doesn't work. Okay, my applet is open.
Okay. Answer the first two problems.
Number 3, and it says to round to 3 decimal places, but don't do it until after your calculation is complete.
Mm-hmm.
Okay.
Yeah. So the first one is to find the combined area under the standard normal curve that is to the right of the z-score and to the left.
1.3.
So what is it?
Did someone say, what's the z-score? 1.3.
85? Is that what they said?
85?
85?
No.
No.
5.8.
Yeah, sorry about that. 1.358. Thank you.
I got 1, but I'm doing it wrong.
I got 0.1745,
Yes.
but then we're supposed to round, so 175.
Well, isn't that when we had a problem last time?
It says round your answer to 3 decimal places.
So 1.175, you said, right?
Yep.
Right.
Okay.
Does everybody like that?
0.175,
Sounds
yeah.
good to me.
Yep.
That's good.
Yep.
Because it's the combined to the left and to the right. So just those outside triangles.
Okay.
Right and to the left. Yes.
Number 4, will have a smaller standard deviation if 9 observations are randomly drawn from a population.
Which of the following?
Distribution of sample means? I'm looking at my notes.
Okay,
Following will smaller.
the distribution of the individual observations, the distribution of the sample means. Do we have enough information? Or is it a rule of thumb?
9 observations.
Not sure.
No, I don't think there's enough because it only talks about larger samples. It doesn't say anything about small. I didn't see anything about smaller samples. So maybe not enough. Because here's one that would kind of, it says if the sample is large, the random variable will be approximately normally distributed. In other words, the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. So
I'm
I would
sorry.
say,
What do you think, Marie?
I would say that there's not, it can't be determined.
Yeah, because, yeah.
What do you think? Lacey, you agree?
Yeah, that sounds good to me.
You can try it.
Yeah.
It doesn't make sense at all, so.
Yeah.
It must not have enough information.
Dagnabbit.
Good. Okay. Which of the following results implies that the spread of x's decreases as the sample size increases?
Which of the following results implies this?
That's the law of large numbers. Yeah.
Because the theorem implies
It's the law of large numbers because the law of large numbers says if the sample size n is increased, then the standard deviation of the sample mean will decrease.
Yeah.
Okay.
Thank you.
Wow,
That's great, Marie. I'm having a hard time hearing you, Marie, and I apologize.
No, it's me because I'm at Starbucks because my daughter had a banquet tonight and I tried to connect to the Wi-Fi at the table, but I couldn't. So I had to rush somewhere so I didn't miss again.
Okay.
So do you guys think it's the law of large numbers?
Yeah.
Yeah, I found it.
Yeah.
I saved it.
Yep.
Okay. We're number 5.
Number 6. Number 6.
Oh,
Yep.
sorry, you're right, number 6. I apologize.
Okay. Scores on the quantitative portion of the GRE are approximately normally distributed when mean equals 150.8 and standard deviation equals 8.8. Deanne earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? Relative
Okay.
to the 3 decimals. So this is just basic Z-score, right?
Right, I think.
Mm,
Because what's our standard? Oh, wait, I like 160.
No, so don't we use the formula?
Yep.
But isn't this is just the standard Z-score?
Right, so it's x minus mu over standard deviation, right? So it's 160 minus 150.8, and then we divide it by the standard deviation, which is
Correct.
8.8.
Correct.
Okay, so let's try it.
Okay.
So I got for a Z-score 1.045,
Same.
Yes.
and they just want the Z-score, right?
Yes.
Yes. Yeah.
1.045.
Yeah. Okay, and then what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
So then we plug the Z-score into the applet, right?
Yeah.
And then
So,
go above 160.
right.
Mhm.
So it was 1.045.
Right?
So above 160 would be,
Only the right side? shaded?
yeah, 148, I get.
That's what I got too. 0.14.
0.148.
Okay.
Okay. Next.
Number 8. Go ahead, Michael.
Okay. A random sample of 5 students was selected to take the GRE. Their scores are that. What is the score corresponding to the sample mean of these students?
Harder song.
So we have to get their mean first.
Yeah.
Yeah.
I got 800 divided by 5. Oh, sorry.
Correct, that's what I got. So 160 again.
And, okay, so that's the mean, and then n equals 5. Okay, and so what is the Z-score?
But if you do 160, if you do the mean minus,
What is the Z-score corresponding to the sample?
if we do 161 minus 160, isn't that 0? So it just is 0.
Wait. Okay, because the sample mean is 160, right?
This is
Yeah,
This is
yeah, that's why I'm,
Go ahead, Michael.
This is where you put that equation that we learned about from this lesson.
Oh, with the sample size, we include the sample size?
Yeah.
'Cause so, because it's, well, wait, wouldn't 160 minus 160 be 0?
But that wasn't the mean. The mean is 150.8.
Oh, I see what you're saying. Because we have, but that's the sample mean is 160, right?
Mhm.
Yeah, but the actual mean.
Oh, was the one from up above.
150.8. So then we need to,
Gotcha.
then we put the standard deviation underneath it and then divide it by the square root of 5.
Yeah.
Okay. Okay. Well, the square root of 5.
Does it have an answer yet?
Not yet.
Hold on.
9.2, 3 point. I have 2.3376, and then if you round up, it's 2.338.
That's right.
And that's a z-score we're looking for, right?
Yeah, that's the z-score of that mean.
Of that mean, and that's 2.338, and that's been rounded up.
Right. Oh my goodness gracious.
That's, and we're on, okay, so 2.338.
Did everyone else get that yet?
I got that.
Okay, are we waiting for anybody? Are we going?
I'm good.
Okay.
Okay.
I'm ready to go on, but I don't know if everybody is. Well, there's 15 questions. Weeks. What?
Okay, so number 9 goes on with the next one. So it's just, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So,
Do we put, do we just put,
You just put the z-score in.
so 2.338?
I got 0.0096.
I got 0.0097.
Right. I got the same. So
So what do we round that up to? 0.01?
0.01.
You went around it. It says round to 4 decimal places.
Oh, it does. You are right.
Oh.
If the answer is, then you would enter.
Okay, so then it is 0.0097.
yes.
And that's if it's a greater. I'm ready.
Okay.
I'm ready.
Okay, well, I'm in the middle of this. Okay. All right, I'll be there. I'm quitting. Okay, bye.
Okay, next one. The Use the following information to answer the next 5 questions. Suppose the mean GPA of BYU students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 will be drawn. What is the
Okay.
shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 selected students?
It's going to be approximately normal, right? Because it's got 81 samples or 81. So it's going to, because that'll make it normal-ish.
Right, because it
Yeah.
says it's a
Well, it's
large
got
number.
81 students, not samples.
Well, it says 81 students. So
It's more than
there's
30.
81.
A random,
more than 30.
It says a random sample of n equals 81 students will be drawn.
So how do you know if it's big?
I don't know if it's big, anything over 30.
Yeah, anything,
Anything over 30.
The deviation is also very small.
Yeah.
Yeah, that's true.
So it should be normal, right? Approximately normal.
Mm-hmm.
Yes.
Okay,
Someone go.
let's go.
What is the mean of the distribution of the samples, of the sample mean, sampling distribution for all possible samples of size 81 that could be drawn from the parent population? Round your answer to 1 decimal place.
Okay, so is this just a regular thing, our x?
No, that's the one where we use the,
Is that just the samples? Does this mean that it's going to be 3.5? Because it's the same, the mean of the sample is also the same as the parent population mean? Does this mean it's 3.5? Because it's the same?
Yeah.
Because that's what is that the central limit there? No,
Yes.
that means, because
The sample
no,
mean
you're right,
and the
you're right.
population mean are the same.
so it should be 3.5, because that's what the original mean is. But just go ahead and correct me if I'm wrong.
I think that's right.
Okay, so the answer to number 11 was 3.5?
Yeah.
Yep.
Yes.
Okay,
What is the standard deviation of the distribution of the sample means for all possible samples of size 81 that are drawn from the parent population?
0.7?
Yeah.
so,
0.7?
because that's the standard deviation. Oh, wait, for all possible sample sizes, it could be drawn from the parent population. So we don't have to plug that into a formula?
I don't believe so.
I don't think so.
I'm looking.
Should we look at, let me check, for all, because we only have one value for, we only have those 3 numbers, right? 3.5 and 0.7 and 81.
Oh, wait. Okay, guys, the standard deviation of the sample mean is standard deviation over mean, the square root of mean.
Because to plug it into another formula, wait, we'd have to have more numbers.
So, no, because it says, from our notes on Tuesday, it says mean and standard deviation of the distribution of sample mean. That was the heading, and then it says, one of the points was, the standard deviation of the sample mean is standard deviation over the square root of mean.
Okay,
Oh, okay.
you mean the square root of the
Yes.
n? So that's the 81, right?
Mhm.
So it's 0.7 over 9.
Yeah.
The square root of 9?
But the square root of
The square root of
81.
9 is 9.
Oh, sorry. Okay, yes.
This has got a bunch of sevens in it. 0, 7, 7, 7.
Yeah.
So that means it's 0.0778. Does it say round to 3 decimal places?
Decimals. Yeah.
0.078.
078. Yeah, 078.
Because I'm looking at
0.0778. That's what I have.
Mhm.
0.078.
078?
Oh,
Or
right,
between
because you're right, because we just need 3 decimal places. Yay!
Okay.
It's like brain surgery.
Because I'm looking at, just really quickly so we can make sure that we're correct on this. Question 3 on one of the sample problems from the text says, what is the standard deviation of the distribution of all possible sample means? And then it gives the formula, standard deviation over the square root of n.
And, yep, you're right.
Okay.
Good job.
Okay. So we'll do 13.
Okay, so number 13.
Mhm.
What is the probability that the mean GPA for 81 randomly selected students will be less than 3.3?
So we have to find the z-score, correct?
Okay, 3.3 minus 3.5 over. And we're going to use that sample size.
Mhm.
Okay, so 0.7 over the.
Wait.
You stick baby on the freezer.
Point
I can take them off that.
two. So I have a z-score of negative 2.574, but that's the z-score. That's
Let them do it. Everything else is too cold. Everything else is too cold here, baby. It's too uncomfortable. Cold.
okay. So what did you guys get for your z-score?
I ran into a problem. We don't have the sample mean.
It's
The
80.
sample mean is, isn't it 3.5? So
What's the mean?
Wait.
the population mean is 3.5, right?
Yeah.
Yes. It's the same thing.
And then it says that's the score, and so 3.3 would be the x, the bar x.
So I
X
got
bar.
negative 2.57.
So I got, negative 2.574.
Yeah. But
And then when you put it in the applet, it's like 0.005 is the area or the probability.
yeah.
What did you get? Point. So I got the same, negative 0.257.
Yeah, I'm drawing a blank here. The sample size is 81, right?
No,
No,
the sample size is 81.
81.
Okay. The
N
standard
equals
deviation
81.
is
standard-
0.7, right?
Yes. And the population mean is 3.5, And then
Okay.
they want you to find what it would be for 3.3. So on the top of your equation is 3.3 minus 3.5.
Which gives you negative 2.571.
Mhm.
Right.
Okay.
And then we put that into the applet.
And they want to know what would be less than, so it's just that little space to the left of that, negative 2.574.
So 0.3986.
I got 0.005.
0.0092.
Oh.
Okay, so do we need to redo it because we each have different answers?
No,
I
wait.
got my number.
Okay,
So what did you guys have on the bottom of your equation?
0.257.
It
Wait,
should be
wait.
2.571.
0.571?
My Z
I got-
score is negative 2.574.
1 second. Let me go back and check.
No problem.
Well, I got the same as Michael. I got negative 2.571. Well, it's negative 2.5706.
Yeah, so negative,
So negative 2.571.
sorry. 2.57. Got it. I was going to use that one.
Because you take the 0.7 and you divide it by the 9,
Yeah.
right?
So you get 0.0051, you said?
I got, again, 0.077777, right?
No, I'm saying for the, once we plug the Z-score in, that's what you got?
I got 0.0051 for the area.
Okay, that's what I got too.
Okay, I have 0.005 for the area as well.
Okay.
Okay, and
Sorry.
Okay, we're
no,
all
those decimals are gonna kill me.
round your answer to 3 decimals.
So just 0.005.
0.005.
For 13, we all agreed was 0.005. Okay.
Yes.
Yeah.
Yeah.
Alright.
What is the probability that the mean GPA for 81 randomly selected points out of those students be greater than 0.3?
So we
So
just
now we just put it,
plug it in.
go ahead.
Yeah, so we just plug it in for greater than. Right?
Wouldn't it be the same?
Yes, unless we're shading in.
Oh my goodness. So does that mean?
I got the same answer.
Yes,
Well, do we need everything above that negative Z-score? So we need the whole curve except for, we need the middle and we need the right. So we need the 99.5.
no, it can't be the middle because it has to be greater than the positive, right?
Well, no, because the Z-score for 3.3 is negative 2.574. So then you have to have everything above that Z-score, right? Because our last problem was not a positive Z-score, it was a negative one.
Mm-hmm. So you do it for the right.
So
I don't know.
0.9949.
You guys push back. If I'm wrong, please tell me. Because we just figured out the Z-score for 3.3, and it was a negative 2.574.
So this one
So
will
we need everything above it. Right?
Yeah.
It's okay for me to be wrong. So please don't feel like you can't tell me I'm wrong, because I'm second guessing myself on everything.
Yes, because yes. Because
One more?
in question 13 we did the less than, and it's the exact same problem.
It's just greater than.
Right. Right.
Yeah, we would use greater than negative.
One more, one more?
One more.
Wait, so
So
what
what if we,
was 14 then?
0.995.
0.99.
It
Okay,
should
yes.
be, yeah, 0.995. Everything's right.
Okay, number 15. The United States Coast Guard assumes that the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boat accident. The standard deviation of passengers' weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample.
So, how's it going?
Note, as extreme or more extreme means that you are not only interested in values that are lower than the ones we observed, but also the values that are far away from ours were in the
This
positive.
is number 2, and you got 3.
Yeah.
So do we just
So
put all
it-
these numbers in our thing?
What's the problem?
it looks like if,
Just can't focus.
He needs to take a break.
I did. I haven't even done any problems since I got back.
but what's N then? Is N the 185?
Nope. Don't talk about this right now. I'm almost done and I can talk to you about what's going on.
Oh, never mind, sorry.
Would it be 48?
48, yeah, sorry.
Okay.
Standard deviation would be 26.7.
Mm-hmm.
Mean is
The mean is the 177.6. Right?
the sample mean.
Yes, the sample mean, the other one is 185.
Okay. Random sample.
Okay, so I have a Z-score, but I don't know what to do with it.
Hold
Find the
on.
probability extreme or more extreme. I don't have it below the mean. Okay.
I know what the calculations, I just don't know what to ask.
So it's asking find the probability that a random sample of passengers will have a weight that is extreme or more extreme. So it's like over the standard deviation of 26.7 or under the standard deviation of 26.7. So
Do they want it at both ends? Like both triangles?
So I think it says as
Not the
extreme
middle?
or more extreme means that are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as are in the positive direction. So it means both that are like and below and the 26.7 above.
So it's everything on the outside.
So we
Yes.
Not the middle, we don't, it's not the middle portion.
the high end, they would have to be 4.3, and then on the low end, they would be,
So is it,
and on the low end, they would be 150.9.
I got 0.049. Wait, 0.0549.
That's what I got too.
I didn't
But
get
then we
that.
have to round it up, right? So 0.055.
If we understand the question right, which means, like, what are the outliers on the left and the right of the, then it would be 0.49. Wait, I don't know. 0.05.
So it's 0.055.
Does everyone have that?
I do. Okay, we
What
got
number did you get
question,
again?
we got question 4 wrong.
Oh, you already submitted it? Wait, so 15 was
So-
0.055?
Yep, it's 0.055. So everything we have right except for problem number 4.
So would it be the distribution of the mean?
So 4 is wrong.
Okay.
Would 4 be the distribution of the sample means then?
Oh my goodness.
I'm looking at it.
So, so the smaller deviation is going to be from the sample mean, right?
Oh, it says that the standard deviation of the sample mean gets smaller. What happens to
It's
the
always
value of
smaller
X?
because the fraction is smaller. So that's where we went wrong.
So it's the distribution of sample mean.
Yep. And then we should have them all right. Did somebody submit it?
Okay,
The
yeah,
right
that was
one?
right.
Yes, that's
Okay, excellent. So did everybody get the 100?
Yeah.
Yay, Lacey!
okay.
All
I'm
right.
clever about what to do.
Okay, so that's 100?
Yep.
Okay.
Okay.